Hello everyone. In this video, we are going to say about units. That is, this is the part one of exploring measurements, part one. So, myself, Mr. Dinesh Kumar, working in Hindustan College of Engineering and Technology in the Department of Chemical Engineering. So, here we go with the current slides. Okay. So, this is actually what is a unit. So, unit is nothing but anything that gives us a quantifiable number, and after that, it should give some measurement related values. So, that is what a physical quantity. That is simply we can say it as a physical quantity. So, unit is nothing but a physical property that can be measured and described by a number is called physical quantity. Okay, so there are two different types. When it comes to the physical quantity, there are two different types. One is a fundamental quantity, and the another one is a derivative quantity. So you just see the examples for the fundamental quantities. So that is a mass, time, length, and a temperature. So similarly, go with the examples for the derivative quantity. You can see area. The unit for area is a meter square. Speed for speed is it is meter per second. For volume, it is a meter cube, and for force it's a newton. So you just compare the example. If you just compare the examples of fundamental quantities and derived quantities, you can get a little bit of an idea. So what is a fundamental quantity and what is a derived quantity? So that is nothing but fundamental quantities just having basic quantities. That is, without mass you can't get volume, or without mass you can't get a density, that is kg per meter cube. So mass is a fundamental thing, only kg is there. When it comes to the time, only second is there or hours is there. And length, for the length you are just having a meter, and for the temperature you are just having a degree celsius or kelvin, or something related to the temperature scales. When it comes to the derivative quantity, it contains one or two fundamental quantities, not one or two. It is two or more fundamental quantities combines to form a derivative quantity. So this is the two basic different types of physical quantity. Okay. So here we go with the units of measurements and characteristics of units. So units of measurements is nothing but how we are going to analyze. So we have already seen it in the previous slide, that is meter, foot. When it comes to the meter, in the CGS type it is for the FPS type we say it is a foot. In some way it may be says as an inch. So it goes with the length, and for mass we can say it is a kilogram, pound. There are different quantities, different notations are there. So why there are different notations we will see in further. Okay. Then characteristics of units. So characteristics of units is how the unit should be. It should be well defined and suitable size, reproducible, invariable, indestructible, and internationally acceptable thing. So internationally acceptable thing is a major point, because each country follows a different types of unit derivation. That is, there are three different types. That is what we are going to see in future. So well defined means if it is says a meter, that is 1 meter equal to 100 centimeter, 10 centimeter equal to 1 decimeter, 1 centimeter equal to 10 mm. Those things should be well defined. The similar way, all the units should be well defined, and it should be suitable size. If you are going to say something, it is 1 meter, no, it should be in 1 meter. Okay, and reproducible, invariable, and indestructible. Okay, so here we go to another slide, that is what are all the types of units that is being so far used. That is CGS, MKS, and FPS are the three major unit types. So one is CGS, that is uh, centimeter, gram, and second. So it is just an abbreviation, that is centimeter, gram, and second. Centimeter is nothing but a length, gram is for kg, and second is for time. So in the similar way for the MKS, it is meter, kilogram, and second. So that is MKS unit. So this is CGS unit. So first letter for C, G, and S. Okay. And for the last one is, you can see foot, pound, and second. So FPS unit. So in all the cases, second comes as a common one, but still in some cases they use a different one. Okay, so these are all the three different types of units. Each types of units followed in a different country. For example, if you take a CGS unit, it is being followed in CGS types of units is followed in a France. Okay, actually it was originated in France, and France people are still using that part. But when it comes to the MKS unit is we Indians usually use this MKS unit. But when it comes to the FPS unit, this FPS unit is mostly used by USA. Okay, so there are different aspects of usages. Okay, in most cases, CGS is not being used. It is not currently not using properly. Okay, so these are all the three different types of units, and there is an international SI unit. Okay, so the international SI unit is for, as you have seen, there are three different types of units are there. So to overcome the problem, to overcome the conversions for scientific thing, for scientific purpose or industrial purpose. For example, if you take a NASA, they are collaborating with Indian government, trying collaborating with the Tesla or collaborating with the Elon Musk's space agencies to launch rockets. So if they are using a different sets of conversions, if they are using different sets of units, it will take much time to convert those units. If they are using FPS and they are using CGS or MKS, so to convert those things, it will take much more time. So internationally, all over the world, all the countries should follow the SI unit when it comes to the scientific purpose and industrial purpose. So that is where the SI unit came into work. So what are all the fundamental units? Seven fundamental units are there. So first one is a length. Okay, so the first one is a length. For the length, everywhere it should be mentioned as a meter. Mass, it should be a kg. Time, it should be a second. So there is nothing different between an MKS and here. Okay, and another one is a temperature. We normally use a degree Celsius, but here it should be mentioned always a Kelvin. And electric current, it should be always an ampere. Luminous intensity, that is the power of light, it should be always a candela. And amount of substance is mole. Okay, so these are all the symbols that should be used before the numbers. Okay, and these are all the fundamental quantities. This is the SI units of this. Okay, there are seven units. There are seven rules we should follow while writing the SI units. We have seen there are seven basic fundamental units. To write it, to write it in a proper way, there is a seven basic rules to how to write the SI units. So the first one is a while writing a person, for example, if you take a Newton, it should be mentioned as a small letter. Okay. Normally, when we are writing a person's name, we first letter we use it as a capital. But when it comes to the here, the first letter should be a small letter. So Newton, Ampere, Coulomb, everything is a person's name. But when we are writing it in the unit format, it should be started with a small letter only. Okay. And if you are going to write it in a very short form, it should be mentioned as just for n. Okay, not a small n, it should be a capital N. Okay, again goes with the scientist name. Okay, so third one is when you are going to write for a meter. Okay, a meter, second, kilogram, and candela. It should be mentioned like this only: m for meter, kg for kilogram, second for s for second. Okay, like that. So if you are going to write it after a numerical number, it should be given a space. Okay, after a numerical number, there should be a space. Okay, then only we should write the symbol of the SI unit. So these are the first four rules. And the fifth rule is the unit should not have a plural forms. So it is not a meters. If there is a 6 meter, it's 6 meter. 14 kg, 14 kg, not 14 kgs, 5 kgs, and 20 second, not 20 seconds. So should be the unit should never be in a plural form. Okay. And the sixth point is full stop. We should not put the full stop after every unit. So here see there is a full stop. Here there is a full stop. Here there is no full stop. Okay. The similar way, no space is used between the symbols for units. Okay. If there are more than two fundamental units or two derived units in a particular value, we should not write it with a space. It should be written without a space. This is a Newton meter. This is volt and ampere. This is joule second. So if we are going to put a space between those things, it will give a different meaning. So this is a prefix for short form and long forms. So this is the basic fundamental for units. So what is a unit? What are all the types of units? What are all the rules should be followed while writing out the units? So these are all the things that we have seen in this video. And in future, we are going to see part 2, that is what are all the dimensions, or how the dimensions can be converted into one form to another. Those are all the things we are going to see in the future. So I hope you people understand what is being taught here. And if you have any doubts, just put it on the comment. Thank you.